Hello. Hello and welcome to this video. In this video, we will learn about two things. One is the new type idiom and the second is the associated types. So the examples have come from Rust by example and I'll try to elaborate that what is going on here. So first we study the new type idiom. So suppose we have two structures. Both have member I64. Now, the structure here, its implementation has a 2 days function which returns days. It takes the argument, the 64-bit integer, multiplies it with 365 and returns it by calling days. It constructs a days object and returns that. And similarly, the days structure, what it does is that it takes the days and convert that to years. It truncates the fractional part, it is an integer division. And then we have isAdult function which takes years and returns a bool by comparing whether age is 18 or not. Now you would see that this years or days wraps an I64 type, okay? But even by wrapping it generates a new type. So that in the age you cannot pass days. You have to give years. So for example, we have constructed two objects, age by calling years and passing 25, and then we convert that to number of days and we call it age days, and in the adult we pass the age in years and we can pass age days to years, okay? But if you try to pass age days just as it is, it won't work. Even though what is inside is I64. So it says cannot reference ampersand years, find reference ampersand days. So let's run this example to see the output. So it is new type. We say cargo run. So in both cases it gives true. So another logic you could say that, say for example, you want to say pass it 64, okay? It will be difficult in this code because I will show you what is the problem. Suppose you change it to I64 and then you pass age dot 0 and age dot 0. So syntactically this is correct, okay? But the problem you quickly notice that if age days is not or rather is greater than 18 days, even then this bool will return true, which you don't want, okay? You don't want someone 18 days old to be entering some age restricted area. So it would be best that you don't do this. At least in this cooked up example, you don't want to do that, okay? So this is the new type idiom where you can construct new type with primitive type. You can compose them also. It is not necessarily have to be one value. It can be multiple values. You can do stuff with multiple values. So your struct basically becomes a new type. Then we move on to associated items type. So suppose we have a container structure of two 32-bit integers and we have a trait contains which takes two generic arguments and it has three methods: contains, first and last. Contains return boolean and first and last return I32. Now you see that the contains, when it is implemented, you have to mark it I32. And then contains tells you whether the first element is equal to number 1 and second item is also equal to number 2. Number 1 and number 2 are the argument which it will receive of these types. Now first is simple, it returns self.0 and last returns self.1. Now we look at a difference method, generic method, which takes ABC. C is of type what you call container, or rather, yeah, container is of type C, and then T is bound by contains state. The container is bound by the contains state A and B. So the container should implement the contain state. Here container is implementing contains state. But see, the problem is that you are forced to write I32 here. So it's a bit of unwieldy stuff going on. Here you have to write ABC. So one of the syntactical improvement is that we define the type trait which contains type A and type B. Okay. Now, if you see the trait, it does not have generic arguments here, but those are type A and B. Contains remains same. Okay. Not remain same. I32 is replaced by A and B. Okay. Now, if you look at contains here, and if you look at contains here, you no longer have I32 here. So it specifies what types and A, B are here. So we specify that as 32-bit integer. If the input type is container I32, the output types are determined as I32 and I32. So Boolean is 1, and then we have I32 and we have I32 here. Okay. So instead you can simply say, I believe A, and I believe A also you can say. Okay. It should work. Let me see. You might have to use the associated type self example. Okay. So this is how we can specify. Now, if you look at the different state, the container does not receive A and B. It simply calls last and first. Okay. So as long as container is supplying I32, things will work out very nicely. Okay. It is syntactically simpler. You don't have to give the parentheses everywhere. So this is the associated items idiom of Rust, and you can make it, you can use it to make the code more readable. If you want, I can show you by running the code. So we have associated items 2. Sorry for the name. So we say cargo run, and there you go. So that was it. I think I'll keep this video short. There is not much else to discuss. I think in generics, one more topic is remaining from Rust by example, that is about phantom data. And then we will move on to lifetime borrowership, borrowing, and those kind of topics. What is mutability and immutability? What you can do with that kind of stuff? How mutability restricts the borrowing stuff? How to simplify code while borrowing things? And you will have more of these problems in multi-threaded code. Borrowing actually becomes complicated in multi-threaded. In single-threaded code, it is quite easy to manage lifetimes and borrowing stuff. But when multi-thread program happens, the lifetime guarantees are far more difficult to satisfy. Single-threaded is still much easier to do that. So after this, we will go through the lifetime and borrow checker of Rust. After that, I will go with standard library. We will discuss not all of it. We will discuss some of standard library things like vector, list, and those kind of basic stuff. Map also we will discuss. And after that, I plan to go through iterators and do functional programming. And after that, we will do multi-thread programming. So multi-thread programming is when the lifetime guarantees are involved, and those guarantees make sure that the code is correct, and they also define or rather restrict how efficient the program is. For example, if you clone all the objects instead of borrowing all the time, then the efficiency will not be there. Copying the objects is quite expensive, and you should try to avoid that as much as possible. But in certain cases, that is not possible at all, particularly in multi-thread program. Sometimes if you pass a value and then you want to use that value by borrowing or something, some sort of nonsense you do, it just wouldn't work. If the compiler will complain that there is no guarantee that this value returns after the thread has exited. So those kind of things will happen. So we'll see how it goes. So for now, you can refer to these codes. These are on Rust by example. You can take the code from there. I have taken from there. And next, we will discuss phantom data in this series. And in the next video, I will also include lifetimes and dry and borrowing and mutability. So thanks a lot for watching the video. I hope that you have enjoyed and found it useful. So I'll see you in the next one. Till then, enjoy.